Here's Conspiracy Cat's math for the Blackpool Tower observation. He's got 0.526 degrees for the angular size of the mountain, and he's got 0.496 degrees angular size of Blackpool Tower. So it's pretty close. It's within 3/100ths of a degree. So we're going to draw a line. There's supposed to be hundreds of meters missing at the bottom of the mountain. So I'm going to draw two lines of the same size. So we draw the line and we label it 0.496 degrees. That's the angular size for Blackpool Tower. Now we draw one for the mountain, label it 0.526 degrees. So there's a 3/100ths of a degree discrepancy, but if you look at the bottom, there's just a smidge, just a little bit of room to get to the water. You know, we could probably call that 3/100ths of a degree, that little gap between the bottom of the line and the water for the mountain line. So I wanted to welcome Ranty back to Flat Earth and get him this message, let him see the video, because it turns out that there's not hundreds of meters missing from the bottom of the mountain. It turns out that that the town behind Blackpool Tower won't be underwater after all. So welcome back, Ranty. I'm going to give you one more demonstration here of how his calculations are horseshit and how you can't compare distant mountains with towers and such in the foreground. Why his demonstration is sound, and he was correct saying that he debunked these observations. Look at these calculations. I won't even have to finish and you'll already see how mucked up and how much horseshit it is. So he's got it here showing a known elevation, and he lined it up, and it says the elevation of that bottom line is 476 meters. And then the mountain behind Blackpool is 753 meters. So that is a difference of 277 meters. So in between them pink lines represents 277 meters. So let's check the angular size for the 277 meters. We're going to go to the triangle calculator. Okay, so I went to the triangle calculator, and you can do this shit by hand if you're a dork and you do trigonometry every day. No, I'm just kidding. But I mean, really, for this, you'd pretty much need a calculator because you need to get the radians for the cosine. But we're looking for sine, which they call theta. So picture the angle A down there. They call theta. That represents where you're observing from. And then side B is the tangent, basically. And that's the distance to the bottom of what you're looking at, basically. So it's 81.7 kilometers, so 81,700 meters. Okay, and then side A would be considered the opposite. So that's what was in between the two pink lines. So that's 277 meters. So remember that the 277 meters represents the distance in between the two pink lines. So we're going to see how it compares. So I calculated it, and it's 0.194 degrees. So remember, in between the two pink lines, 0.194 degrees. And we'll see how it compares up. But to figure this one out here, you'd have to, it's SOHCAHTOA, sine equals opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But if you have two values, basically two lengths in this example, but you could also do it with one angle and one length. But here you have to figure out the radians of the cosine to and then multiply that times the opposite. So anyway, blah blah blah. Let's see how it compares. So triangle calculator gave us angular size in between the pink lines of 0.194 degrees. Now we know that Blackpool Tower from that distance has an angular size of 0.496 degrees. Now you're starting to see the problem here. Blackpool Tower already almost fits in between the two pink lines. So I'm upset I didn't check this out sooner. But they're way off. And this is what it would have to be for there to be a few hundred meters of the mountain underwater. So how he puts it. I don't know if Ruhif had a part in this. I know he did something similar, but they are wrong. Okay, that's what it takes to put a few hundred meters missing behind a globe horizon or a flat Earth horizon. But in reality, look at it. You could double the size of that pink line, and you still wouldn't be even close to the angular size of Blackpool Tower. Blackpool Tower would have to, so they're way off. And I don't know if Ranty did this on purpose, but he's basically that shows me it was almost globe biased, if or either just not being honest. But they are dead wrong. Do the math. The math don't lie. You know, even with refraction, if you want to move the mountain or the tower up or down a little bit, it doesn't work. So I wanted to welcome you back, Ranty. Show you your mistake, bud.